Hey there and good evening. Today I'm making this video about the power rule and how we deal with radicals and with negative exponents. Because sometimes writing an equation that's a polynomial, right, with the powers is how we're going to use the power rule. But sometimes we forget about the rules for our exponents. So let's first do some manipulations. I think I have 1, 2, 3, 4, maybe 5 of these. So this shouldn't take too long, but let's talk about this. The first thing we're going to do here, this is k times root x plus x times root k. So we're going to manipulate this so that we actually have some powers, right? We can't use the power rule without having powers. So we're going to change my root x to x to the 1/2 power. Okay, and then I'm not going to change the root k because k is not the variable we are differentiating here. We are doing dy dx, so k is going to be a constant in this case. So we're only really concerned about making the x powers, well, the x's into powers. So now that we take the derivative, we multiply, right, the power into the front, so 1/2 of our k value times x to the, we subtract 1 from the power, so 1/2 minus 1 is negative 1/2. Okay, and then plus the derivative of k root x times root k is just root k. Okay, so we have to do one more thing, and that is deal with this negative power. So to deal with the negative power, we put it under the in the denominator of a fraction. So we have 1/2 k, and then we have 1 over x to the 1/2. Okay, and then of course plus root k right here. So we can combine these things. I'm going to rewrite x to the 1/2 as once again the square root. So we look at all the things in the denominator. That is a 2 and a square root of x, because x to the 1/2 power is root x. And I have k as my numerator, k times 1 times 1, plus root k, and that is going to be my nicest way of writing the derivative of our original y equation, k root x plus x root k. Okay, so here we already have our equation, and it has some nice negative powers, so we're going to apply these rules straight away. We're going to take our powers and multiply them to the front of our variables, so y prime equals negative 1 times x to the minus 2 when I subtract 1 from the power. Okay, and of course a plus 2, a negative times a negative is a plus, so x to the subtract 1 from the power minus 3. And then the derivative of 3x is just 3. So once again, I'm going to deal with these negative powers by putting them in the denominators. Okay, so I'm going to move everything down. Negative 1 stays in the numerator, x squared, plus 2 stays in the numerator, x to the cubed, plus 3. So only the variable that's raised to the negative power, only this gets put in your denominator. Your numbers, if they're not already in the denominator, don't. So only the exponent and the base that's connected to it get moved into your denominator when you're applying this exponent property. Okay, so here we have another radical that we're going to have to change before we do our derivative. So we write this as x to the 1/2 plus x to the 1/3. So the third root is the 1/3 power. And now we can apply our power rule. So we'll bring the exponent to the front, and we're going to subtract 1 from each of these as you take the derivative. So this becomes 1/2 of x to the negative 1/2 plus 1/3 of x to the negative 2/3. 1/3 minus 1 is negative 2/3. So once again, we're going to take our negative powers and move them into denominators. We'll see what happens here. We have a 1 in the numerator, and we already have a 2 in the denominator, times 1 over x to the 1/2, plus 1/3 wow, that's a terrible looking 1/3, times 1 over x to the 2/3. Okay, so once again, I'm going to change my x to the 1/2 back into a radical, 2 root x. Okay, it just looks nicer in the denominator than an x to the 1/2, plus 1 over 3. Now, we still have a 3 in your denominator of your fraction, so that's going to be our root, and x squared is going to be the power. So if we have a fractional power with two terms, right, a numerator and a denominator, the denominator is the root and the numerator is the power or the exponent of that fraction. So that's looks a little something like that. 1 over 2 root x plus 1 over 3 times the 3rd root of x squared. Okay. So once again, we're going to deal with these and move our radicals and change our radicals into fractions before we take the derivative. So this is 1 over x to the 1/2 plus x to the 1/2. So I'm going to move my variable with the exponent out of the denominator into the numerator by making it into a positive, or a negative rather, negative fraction. So we're undoing the thing that we did a second ago. Okay, and I do this so that I can make a nice power and we can bring them to the front. So this is a negative 1/2 comes to the front. Okay, and we subtract 1, same thing here, and we subtract 1. So y prime is negative 1/2 x to the negative 3/2 plus our 1/2 x to the negative 1/2. Okay, so hopefully you're getting the hang of this. We're going to take our negative powers and we're going to move them to the denominator. This is 1 over x to the 3/2 plus, here's our 1/2, and we're doing 1 over x to the 1/2. So now we're going to change our fractional exponents back into radicals. So you have a 1 in the numerator, and this first term is negative. So we have 2 times the square root of x cubed. Okay, remember the 2 in the denominator is your root, so the square root, and the 3 in the numerator is your power. So the square root of x cubed, and then plus 1 over 2 times the square root of x. Okay, would be your algebraic way to simplify that root, or derivative. Okay, one last one here that we're going to do. Okay, so what I'm going to start doing here is I'm going to break this into two fractions, right? If I have the sum on the numerator over one denominator, I'm going to break it into two fractions. So I have x to the negative 2 power over x to the negative 3rd plus x to the negative 1st over x to the negative 3rd. Okay, so now I'm going to make my negative denominators into a positive, so times x cubed plus x to the negative 1st times x cubed. Okay, so if it's a negative in the denominator, when you can make it a positive by bringing it to the top, or the numerator. Okay, so now we have to add our powers. Right? If we're multiplying our like bases, we add our powers. So this is just x to the 1st power, and negative 1 plus 3, that's x squared. So I have a pretty easy derivative, I think. The square root of x is just 1 plus 2x, which is the derivative of x squared. Okay, so in this case, when you did your exponent rule simplification, we got something that was really easy to derive, or to take the derivative of. Okay, so hopefully this tutorial has been helpful, and it will help you deal with radicals or negative powers and when we're taking derivatives.